Hey, Mrs. Radigan here with the last lesson on sequences and series. This one's on geometric series. So we're talking about the sum of terms in a geometric sequence. If the sequence or series is finite, that means it has a given number of terms, a set number of terms. And the formula for finding that is taking the first term and multiplying it by 1 minus r, which is the common ratio raised to the nth power, which is the number of terms, over 1 minus r. So you're going to need the first term, the common ratio, and the number of terms to find that sum. If you have summation notation and you want to know how many terms something has, or the series has, you take the upper limit and subtract the lower limit. If a series is infinite, meaning it goes on forever, the only way to be able to find a sum is if it converges. So when you have a ratio, it could be positive or negative, but it's the absolute value of it is less than 1, so something like a half or a third or 3/5. That value, the very last term, the infinite term, is going to get really, really close to 0, as you can see in this example. And we call that a converging series. So we start out with 1, and then we take half of that, and we get half, and half of that is a fourth and an eighth. And as you can see, this is going to get so tiny out here, it's going to be a speck. So you could actually find the sum of that. And that sum is found using this equation by taking the first term and dividing by 1 minus the ratio. If you have a diverging series, meaning the multiplier is like 2 or 5 or 4/3, something greater than 1, then you have an infinite sum and you cannot find it. Okay, example 1, we're evaluating the finite series. So in order to do that, we're literally just finding the sum here. To find the sum, remember that we need the A1, we need the R, we need the N, and the R again. So this right here is our A1. We can see if we're going from 5 to 15 to 45, our R is 3, and we know that our N is 6. So we're going to plug those values in. So we have A1, which is 5, and that's multiplied by 1 minus R, which is 3, raised to the nth, which in this case is 6, over 1 minus R is 1 minus 3. So we are taking 5 times 1 minus 729 and dividing it by -2. And that is going to give us a sum equal to 1820. In part B, we're doing the same thing. We have an A1 here, we have an N there, and it looks like our ratio is actually a negative this time, and that can create some issues. So be careful when you find the sum. So the sum is still equal to the first term, which is 7, times 1 minus the ratio, which is a -5, and that gets raised to the nth power, which is 8, over 1 minus -5. Here's where we need to follow our order of operations. So this does not become a positive because our order of operations says we need to take -5 and raise it to the 8th power before we subtract it from 1. So when we do that, we actually get a positive number for -5 to the 8th. It is actually 390,625. So this still is a subtraction problem in the numerator. This did not actually become a positive. So just be careful of those negatives. In the denominator, however, because we just have minus and negative and no exponent here, we do have a 6. So we have a sum of 7 times 1 minus 390,625 divided by 6, which is -455,000. 728. In number 2, we're determining whether each series diverges or converges. Remember, we diverge when r is greater than 1, and we converge when r is less than 1. So if we diverge, we have an infinite sum and we can't find it. If we converge, or the value gets really close to 0 at the end of the series, we can find the sum using the formula a1 over 1 minus r. So we first look at the ratio here. It looks like in this case we have a ratio of 1/2. So going from 16 to 8 to 4, we're multiplying by 1/2. So our sum is going to be equal to the first term, which we are given as 16, over 1 minus the r, which is 1/2. So this is 16 divided by 1/2, which is equal to 32. In the second part here, part B, it looks like our r is equal to 3, so that means we are diverging, and we have an infinite sum that we cannot find. In part C, we have 1.1 to negative 0.11 to positive 0.01. If you're not sure how to find the r value, you can just take the second term and divide it by the first term, and that looks like it gives us negative 0.1, or negative 1/10. So that means this thing is converging, and we can find the sum by taking the first term, 1.1, and dividing by 1 minus the r value, negative 0.1, which would be equivalent to 1.1 divided by 1 plus 0.1, which would be also 1.1. So it looks like that sum is just equal to 1. So basically we're subtracting 0.11, which gets us almost back to 1, and then adding a little bit more and subtracting a little bit less, so basically we're at 1. In part D, again, we're looking for our r value. The value that has the exponent is going to be the r, so in this case our r is 2/3. We know it's an infinite sum because of the infinity at the top of this summation notation. We know it's infinite on these because it goes dot, dot, dot. So in this case, on part D, we need to find a1. So in order to find a1, we're just going to plug a 1 in for n, which is also equal to 2/3. So our sum is going to be a1, which is 2/3, divided by 1 minus r, which is also 2/3. So essentially we have 2/3 divided by 1/3. We need to get rid of that denominator of 1/3, so we're going to multiply the top and the bottom of this fraction by 3/1. That's going to make a 1 down here, and it's going to make a 6/3 here, or a sum of 2 there. And then the last one, which is not on your notes packet, but I think it's worth talking about, is a summation notation. We know it's infinity because we've got an infinite sign on the top of the sum. And we know that the r is equal to 2. If r is 2 and we're looking for an infinite sum, this is going to diverge. And again, we can't find the sum on this one, so we just have an infinite sum, not possible to find. In example 3, it says we're talking about infinite geometric again. So the sum equation is a1 over 1 minus r, but we're working backward a little bit here because we're given the sum and we're given the a1 and we're looking to find the value of r. So we're just going to plug these values in. The sum 100 is equal to a1, which is 20, divided by 1 minus r. Now if we want to solve that, the best thing to do is get r on the other side. So we're going to get rid of that denominator there, which gives us 1 minus r times 100 is equal to 20. because this 1 over r and that 1 over r become, or 1 minus r become 1. And instead of distributing, the best thing to do here would just be to divide this by 100. And you would have 1 minus r is equal to 0.2. And then you can subtract 1 from both sides. Negative r is equal to negative 0.8, which means r is equal to positive 0.8. So our multiplier is 0.8. Okay, last equation, or example here. It says the Floyd family is going on vacation. Oh, we are looking forward to that. They start with $125, so that means our A1 is $125. They're saving 8% more than the last month. So in the next month, they actually have their 125 plus 8% more. So their multiplier is actually 1.08. And then it says they want to save for 12 months. So that means our n, or our number of terms, is going to be 12. If we're finding the sum and how much money they'll have total, we're finding the sum. So we're going to use that original finite sum formula, which says we take A1 times 1 minus r raised to the nth power and divide by 1 minus r. So it's probably best to do this on your calculator. If you take 1 and subtract 1.08 raised to the 12th power, you can see that we get negative 1.518 for this value in the parentheses right there. So we are getting 125 times negative 1.518. And we're dividing that by 1 minus 0.8, so we're dividing that by a negative 0.08. And we'll do that on our calculator here. So we're going to take 125 times negative 1.518 and divide it by negative 0.08. And that gives us $2,372. So at the end of 12 months, if they save $125 plus 8% more than the previous month, they're going to have $2,372, and hopefully they can go on a nice vacation. All right, so in summary, when does a geometric series have a sum? It has a sum when it is a finite series, or it is an infinite series with an r, or the absolute value of r, that is less than 1. So something like a half or 2/3. And that's all, folks.